Okay, this is try number 3 for this particular video. So this is 5.1 and 5.2. It's systems of equations. We've already kind of had a little bit of introduction in the fact that we did this in 6.1 and 6.2 already, but that was with our calculator and matrices because I wanted us to be able to do it with that. Since this is going to be, we need to condense this chapter a little bit. We need to use all the tools that we can to make that happen. So just to make sure we understand when we have a system of equations, when we look at it graphically, these are going to be two lines. I'm going to graph both of these two lines. Okay. I like to graph by intercepts. I know when it crosses the x-axis that the y value is 0. So if I put a 0 in for y, I know that x is equal to 5. So I can 1, 2, 3, 4, and 5. We have an intercept there. I can do the same thing for when it crosses the y-axis. I know that that value is going to be a 0 as well. So, excuse me, x is 0 when that happens. So that means that y is equal to 5. 1, 2, 3, 4, and 5. And so since we have 2 points make a line. And we can draw that line in there, and we have the line that represents the equation x plus y equals 5. So any point that I draw, any point that I pick makes this equation true. Okay, we have another equation. It works the same way. 2x is equal to 12, so that means the x-axis is x-intercept is 6. If I cover up the x term, I find out that 3y is equal to 12. That means that y is equal to 4. So there is 4. So I'm probably going to be better off if I find myself some type of straight edge. I wasn't prepared for this, so here we go. Let's make one here. All right, so we have that point, that line. Remember, all the points along this line make that equation true. So something is going to be unique about this point right here. That point right there is the point that makes both equations true. And if I did that right, this should be the point 3, 2. Okay? And that's what drawing out by hand is silly because you have to be pretty exact to get there. But anyway, 3 plus 2 does equal 5. 2 times 3 is 6. 3 times 2 is 6, and 6 and 6 add up to 12. So yes, that is a solution. So that's what we're finding. We're finding the point where two lines meet. Or it could also be where two lines don't meet, meaning I could have this equation. I could have x plus y is equal to, let's say, let's do 2 just for some grins. Let's do that in a different color because I'm going to do it on the same graph. So I know it crosses the x-axis at 2, y-axis at 2, crosses the x-axis at 2. And now we can draw that through there. Obviously, the scale is very good at all. Crooked. Anyway, if I look at that blue line and that red line, they end up being parallel to each other. And since they are parallel to each other, these two lines have no solution. Okay, so we could end up with a system that has no solution. Okay, there are no points that make both equations true. Okay, and the other thing that can happen here is we can have an infinite number of solutions. We kind of talked about it on the other page, but it's a little bit easier to see here. If I can make more noise or be more annoying. Okay, so we're going to make another equation. I'm going to say this is going to be 4x plus 6y is equal to 24. So now I'm going to compare these two equations. So I'm going to compare that blue line with that the first blue line with this green line. Okay, so if I have 4x is equal to 24, I can take out 4x. So that means that x equals 6, which is, sorry, so we're talking about this line again, my bad. X equals 6, so we have an x-intercept here. If we cover up the x term, we get 6y is equal to 24, so y is equal to 4. We're talking about this line here, so those two lines actually ended up being exactly on top of each other. So in this case, we had the infinite solutions. Okay, there's an infinite number of points that make that equation true. Okay, now when we would do the 3x3s and the matrices, we had to worry about writing it in terms of one variable. Here, we do not have that one. Okay, yes, continue. All right, so, but however, in doing number one, that's not what it is. We have different ways to do number one. Number one is just asking us, is 2, -3, is that the solution to y equals 6x minus 15? And the other equation is 3x plus 6y is equal to negative 12. Okay, so we're going to substitute. We're going to go with negative 3 is equal to 6 times 2 minus 15. 12 minus 15 is negative 3, so that one checks out. We're good. 3 times 2 plus 6 times negative 3, we're going to have a 6 plus a negative 18. So negative 12 equals negative 12, so that one checks out as well. So my answer is going to be yes, this is the solution to that system. So how was that for a 5-minute answer for something that was very, very simple? All right, number 2 works exactly the same way. We're going to substitute those points in to determine if we have a solution or not when I have that false statement, okay? Now we're going to learn that there's different ways to solve. Later on, we need to learn the substitution method, because if we're taking a chapter 5 test as the end test, then we're going to have to be able to solve by substitution. If we're taking the chapter 5 test, if we're just rolling the chapter 5 into the final, then this skill will not be on there, or the necessity of that skill. However, we're going to talk about it here, and that made absolutely no sense, but we'll try it again later. All right, so we have x minus 2y is equal to negative 6 is equation number 1. My other equation is y equals negative 4x minus 6. And here's our inherent problem is this. I have two variables in one equation, so that makes it impossible to solve for one variable and have an integer answer. It will always be in terms of the other variable. So that's why I can't just solve an equation that has two variables, okay? I have to get it down to where it has one variable, and that's where substitution comes into play, okay? So I know that y is the same thing as 4x minus 6. So we're going to come over here and we're going to go x minus 2 times y, but y is negative 4x minus 6 equals negative 6. So in the place of y, we wrote 4x minus 6, and now we have an x and we have an x, so now we only have one type of variable in this equation, and now we can solve for that one variable, okay? We're going to distribute a negative 2, so negative 2 times negative 4 is a positive 8x, negative 2 times negative 6 is a positive 12, and now we're ready to solve this. X and 8x give me a 9x. I'm going to subtract that 12 to the other side to give me a negative 18. We're going to divide that 9 across to get x is equal to negative 2. And now that we know x is negative 2, we can come up here. Y equals negative 4 times negative 2 minus 6. That'll be a positive 8 minus 6, which is going to give me a 2. So I know that the ordered pair for this solution is going to be negative 2, 2. Okay, so that's the substitution process. And we'll learn another method where we can, so right now we know how to use a matrix to solve a system of equations, and we can use a substitution method to solve a system, and then later on we'll learn the addition method, but we have to be able to know how to do this. My calculator is not going to be able to solve all systems for me. Okay, so I have to know these other methods in order to get through those other sections. Okay. Again, this is also solving by substitution. So in number 4, we're going to have x equals 4y plus 6. We have x equals 9y plus 1. Both of them have the same exact issue again. I cannot solve for a particular variable without being in terms of the other one. So this is, yes, it's x equals, but it's in terms of y. So we're going to solve this. Instead of writing x, we're going to write what x equals. We're going to get that from the other equation. X is 9y plus 1. So we're going to subtract that 4y to the other side to get a 5y. We're going to subtract that 1 to the other side to get a 5. And so that means that y is equal to 1. Once we know that y is equal to 1, we can come up here. 9 times 1 plus 1, we know that x is going to equal 10. So that means that the intersection of those two lines, if I drew them in a coordinate plane, they would intersect at the point 10, 1. Okay? So we're continuing to solve by the substitution method. I won't solve all of these because the process is the same as we move on. The only difference is how we have to set these up in negative 16, because in this one we have 3x minus y is equal to 29. So this doesn't set up nice and neat like the other ones did. The other ones already had y equals. It already had x equals. This one does not have that. So we have to do a little bit of preparatory work on this. I'm going to add the y to the other side. We're going to subtract the 29, so that means that 3x minus 29 is going to equal y. And now that I have y by itself, now we can substitute this in for x. So this will be 8 times 3x minus 29, except I completely botched that. Ignore that. It's horrible. We're substituting for y, not x. I have no idea why I drew that over there. Hopefully you were screaming at me that I was making a mistake, but if not, it's okay. We don't want people to think you're crazy. Anyway, we should be substituting here for y, not over here for x. 8x plus 9 times y, and y is 3x minus 29 equals negative 16. And now that we have only one variable, x, now we can solve for x, solve for y, and the rest of it works exactly the same. Okay? So I'm just going to stop at setting these up. All right, I've been neglecting my other colors, so here we go. Let's do it purple. So this is solving by the addition method. So this is number, what is this, number 6. Okay. In number 6, one equation is going to be 2x plus 14y equals 4. My other equation is 4x minus 14y is equal to 8. Okay, so this is solving by the addition method. So we're just going to go through the other, this is the last style that we'll learn how to solve a system by. And this is the addition method. So what we're going to do is we're just going to add the two equations together. We're going to have a 2x and a 4x that would add together to give me a 6x. This is going to add together. The positive 14 and the negative 14 are going to cancel, and then that's going to equal, we'll put it over here, 12. So we went from two equations that had two variables into something that only has one variable. So that allows me to divide over the 6 and find out that x is equal to 2. And now that we know x is equal to 2, we can substitute that. 14y is equal to 4. So 2 times 2 is 4. So we're going to subtract 4 from both sides. 14y is equal to 0. So that means that y is equal to 0. I divide the 4 over there. So this intersection, again, if I was to draw that out on paper, they would intersect at 2 and 0. Okay, so this is the addition method, and sometimes we have to know the substitution addition methods to do just be able to solve all types of equations, because I don't want to lead you astray. Yes, I love the calculator and it can do a lot of stuff for us, but sometimes it's going to leave us out to dry. So here's my system of equations. I'm going to do this wrong to start with. I shouldn't say wrong to start with. I'm just going to add these together. That would give me a 5x. That would give me a 7y, and that would give me an 18, and that would be pointless because my new equation still has two different variables in it. So that did not help me one iota. Okay, so what I want to do is I'm going to pick a variable to eliminate. A lot of times we're going to look for different signs. Well, these don't have different, meaning positive, negative. These do not have different signs. However, I know that if I multiply the top equation by negative 4, that will give me a negative 4x here and a positive 4x there, and those are going to cancel out. So we're going to distribute that through. Negative 4x minus 8y is equal to a negative 24. I'm going to recopy that second equation. 4x plus 5y is equal to 12. And now I'm ready to add those together, because now when I add them together, those x's are going to cancel. We're going to end up with a negative 3y, and we're going to end up with a negative 12, okay, when we add those two together. So that means that y is equal to 8. And now we know that y is equal to 8. We can come back over, and it doesn't matter, into the top. I'm going to go into the top equation. 2 times 8 equals 6. That would be a 16, so that means that x is equal to a negative 10. So that means we get negative 10 and 8. Okay, and we've got that guy taken care of. These all work by again, they all work the same way. You know, here again, just because I can, here I'm going to do this. I'm going to pull out my calculator, and we're going to go into a matrix C, and I'm going to edit number 1 here, except this is going to be a there's two equations, so it's a 2 by 3 matrix. So I'm going to go with 2, -3, -1. And we're going to go with 3, -2, and -14. So again, we created the matrix. We're going to quit out of the matrix. We're going to go back to the matrix catalog. We're going to go to math. We're going to arrow up till we come across the operation called RREF. We are going to select then the matrix, go back into the matrix area, and we're going to select the matrix A by name, matrix 1, hit enter, and there's my solution. Remember that x equals -8, y equals -5. So again, these simple, straightforward, linear ones, our calculator can do wonders for us. But we have to be able to know these other methods in case it is something that's non-linear. Okay. Here again, in the last couple is just solving application problems. I will set these up. I won't solve them. So when we talk about number 9, use the given conditions to write that. The sum of two numbers is 7. So x plus y is equal to 7. And it says if one number is subtracted from the other, so it doesn't matter. I'm going to go with x minus y, and the result is 5. So we set up my system of equations. This sets up, again, it's going to be your preference. You can go to your calculator. You can use substitution on this. We can solve for a variable relatively easy, or this sets up really nice to do an addition method. My y's are going to cancel. 2x is going to equal 6. 2x is going to equal 12. X is going to equal 6. Y has to be 1. So you can almost roll through the rest of that in your head. But anyway, here's 10. I'm just going to set these up for you. A company that sells canoes has fixed costs of $22,000. So I have fixed cost of 22. It costs $80 to produce a canoe. So it's wanting me to write a cost function. So the cost function is going to be $22,000 of fixed cost plus $80 to construct every canoe X. So that's going to be my cost function. Then it's going to ask me to find out a revenue function. Okay, that revenue function is I am going to charge $160 for every canoe X. So that is going to be the answer to part 2. Now I want to know, what is my break-even point? Well, your break-even point is when your costs equal your revenue. So I want to find out when this is a substitution problem. And we're basically making $80 on every canoe that we build and sell. And so that, how many $80 am I going to have to make before I can cover up that 22,000? So, and then I think it's going to ask us what the break-even point is and possibly how much money it cost. But again, I was just going through the setup process on that. And last one, a cheeseburger. A cheeseburger plus 2 pan pizzas. Going to jump in there at 2,250 calories. However, if I switch that around and I do 2 cheeseburgers and only 1 personal pizza, we're going to consume 2,460 calories. From that, we need to figure out how many calories are in each one. So again, this sets up to do a system of equations, whichever way you want to do that. You can also use X and Y. You don't have to do cheeseburger and personal pan or pan pizza or whatever it was. It's just whatever you choose, but that's how we're going to set those up. So this one's done.